Hey, hello. I know we've been taking a summer break that and its limits have been before the summers also. So I wanted to make up by making a video about science. The website said it would be coming soon, and I'm recording for practiceforyourb.tk. If you're still watching, today's video is about science. If you heard, today's video is about science. It's not like E equals MC squared, okay? Because that's like adult stuff. But this is like practice for your B.tk. That doesn't do E equals MC2 squared. Whatever, it's confusing me. MC squared. We're not doing it now. Maybe later. But okay, today's video is about black holes. I know, it's kind of interested me for some reason. There are a lot of things you should know about black holes. If you know that they rip things apart that go in, that's great. But did you know you can't see them? The reason you can't see them is because light never reflects off it. Instead, it goes into it. So once it goes into it, it never comes out. So if it goes into it, you can't see it because everything you see is seen by light reflecting off it. Even the animal with the best eyesight couldn't even see it. But I don't even know why it would see it, because you can't see it. Get the joke? Haha. Anyway. Black holes. The thing that interests me is here on Earth, we have Earth time. Earth time is three-dimensional: height, width, and depth. Okay, so height, width, and depth, right? So space-time actually is four-dimensional. The fourth dimension is time. If you read The Wrinkle in Time, they say that you have a five-dimensional thing. They say there's a fifth dimension. It's fiction, okay? It's not true. But I recommend it for kids higher above the third grade, because the book is pretty complex. But I've read it. It's pretty good. I've read it 3 times. Anyway, I know I say anyway too much, but black holes, right? Did you know that let's recap. Space-time is four-dimensional, including time, height, width, and depth, right? What if I were to tell you that large objects in space actually make holes in space-time? So imagine a quilt. Let's say this notebook is the quilt. I put a guy named perhaps Ezra here. See? He's making a hole on it. No. I need something heavier. Say I put this water bottle on it. Whoa. It's making a hole in it, right? So that's like how space-time. So you put a ball on a quilt, basically, right? If you look on the bottom, there's like a bump coming out, right? But say you put a bowling ball on it. It makes a wider hole and may even rip it out. So basically, a black hole actually is the bowling ball and space-time is the quilt. It makes a hole in space-time, so when you go into it, you get ripped up into atoms. There's no record that any earthly object has ever survived or seen one, obviously, right? So, Nothing has ever really gone into it, I believe, because I've never actually heard anything. But it is possible something could have fallen into a black hole. We didn't take the time to notice it. Like a rocket ship, hopefully without the people. Anyway, black holes, right? Albert Einstein, right? He said the quilt, right? This notebook, for example, isn't just like 2D, it's 3D. So that's how it can make a hole in it. Get it? And did you know there's actually there's actually a lot of black holes in the Milky Way here. So to give never mind, that was a bad way. But if you ever find out about an alien, tell him to visit a black hole. Oh, one more thing. One thing you should know about black holes is the event horizon. It's an invisible border. Say, my trusty assistant Ezra here will walk you through the basics. Hello, people. Oh, yeah. So, Ezra, right? Let's say this is the black hole. It's a sword, but it'll be a black hole for now. So, and this is event horizon. If you're outside event horizon, you won't get sucked into the black hole. So if Ezra was, say, here, he'd go into the black hole. But say it was here, he wouldn't go in the black hole. But if you're at the event horizon, you won't get sucked in. Not unless your foot is sticking out. His foot would probably get pulled out, but... Thank you, Ezra. Yay! There's nothing I love more than helping people out. Yay! Ezra, I'm talking. Nice ventriloquist act, right? Oh, we'll go on that word for another spelling bee video. Okay. So event horizon. We've talked about that, right? Have we talked about... We have talked about event horizon, space-time, and... Okay. Not just black holes make holes in space-time. You know, the sun has a hole in space-time. Every single planet, any large object, has a hole in space-time. So, you know what happens? The things, if you were ever to record an experience about going into a black hole, which is, in theory, you couldn't record it, right? Because event horizon, point of no return, blah, 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 blah. But if you were to, you would say your torso up to here would get pulled off. But you wouldn't die because you don't need that. But you'd surely get ripped up into atoms. It's a pretty gruesome process. But anyway, black holes. Okay, let's talk about how they form. Black holes form when a star collapses. That's one of the two ways. The other way is too complex. Okay, so let's say this is the star, right? So gravity goes this way, into the center of the star. But when the star starts dying and running out of fuel, its gravity goes out, right? So once it goes out, it collapses on itself, therefore forming a black hole. And then, you know that gravity that goes in, the thing that pushes it out? This is the pushing force. It's weaker. This is the stronger force. This pushing force is available only at event horizon. This is available after event horizon. Confused? Okay. So event horizon has the pulling process, which pulls you in. And this one has the pushing process, which once you're in, it makes you rip into atoms. So you go in 4 directions. Get it? If you're confused, maybe you should, I don't know what you should do, but I hope you understood. The other way is too complex, like I said. Black holes. Have you ever seen a movie about spaceships? And then there's a force that pulls it into? That, even if those spaceships existed, that'd still be fiction. No one can see a black hole, like I said. It's kind of interesting, don't you think? Anyway, thanks for watching. Practice for your B.TK, and I hope you will watch again after our summer break. Thank you. Please subscribe.